Hello, what is up? This is day 6 of our 25-day daily push-up challenge while solving a Putnam problem. So here we go. 1, 2, 3, 4, 5. Okay, so I started with a 5 push-ups right there before reading the problem, because yesterday the problem was so straightforward. Before even doing any push-up, we were able to solve it. So now, before reading the problem, we start with 5 so that we are guaranteed at least 1 push-up, so that we don't have to do 25 straight, which is something we want to avoid. Anyway, the question is from Putnam, 1993, and it reads: the horizontal line y equals c intersects the curve y equals 2x minus 3x cubed in the first quadrant as in the figure. Find C so that the areas of the two shaded regions are equal. So it's very similar to the equal area problem like we had yesterday, but instead of like geometrical figures, here we have a line and a curve. 6, 7, 8, 9, 10. Okay, so what I'm thinking is to start this, let's call this point where the line first intersects the curve, let's label that as A, and then where it intersects it again, right here, let's call that x B. Okay, so that this point, it has the coordinates AC, this point has the coordinates BC. Okay, and to solve for the area of the first region right here, okay, the one I'm shading right now, the first region there, it is just equal to the integral of the curve above it, in this case the function c, minus the curve below it, okay, bounding it from below, which is in this case the curve 2x minus 3x cubed. So we have the integral from 0 to a of c dx minus the integral from 0 to a of 2x minus 3x cubed dx. That should be equal to the area that I'm shading here right now, okay? And this will be given by the reverse, so the curve above, which is 2x minus 3x cubed. The area below it is you integrate from a to b dx. You subtract it by the curve below, which is of course c, integrating it from a to b, okay? C dx. So that's the setup. 11, 12, 13, 14, 15. Okay, so right here you can put all the c integrands involving c in the left hand side. 0 to a c dx plus integral 0 a to b c dx equals, and then all those involving the curve 2x minus 3x cubed, you put it on the right hand side. Integral from 0 to a 2x minus 3x cubed dx plus integral from a to b 2x minus 3x cubed dx. Of course, the left hand side you can simplify, because 0 to a, integral from 0 to a plus integral from a to b with the same integral, that just simplifies to integral from 0 to b c dx. Similar on the right hand side, we have integral from 0 to b of 2x minus 3x cubed dx. Okay, 16, 17, 18, 19, 20. Then we integrate. Oh, I pressed home and lost the notebook right there. But anyway, let's continue. Okay, so we integrate this particular equation. So right now we have, okay, the integral on the left hand side is trivial, that's just cx. Evaluated from 0 to b, that's just bc. Okay, that's equal to the integral on the right hand side all involves x on the term, so we forget about the zero limit, we just focus with b. So the first term is x squared over 2, and then you have a 2 coefficient, so that just becomes x squared. So this is b squared. Okay, and then the second term will be minus 3 over 4 x to the fourth evaluated at b, so that's minus 3/4 b to the fourth. Okay, and note that at point C, okay, at point where the curve intersects the line, C is given by 2 b minus 3x cube. Sorry, 3b cube. Okay, basically the value of 2x minus 3x cube at b. Okay, so now we substitute that in this equation. This equation further simplifies to, let's see, 2b squared minus, so you have 2b squared minus 3b to the fourth, okay? And of course, the right-hand side is still b squared minus 3 over 4 b to the fourth, okay? So let's simplify this. Let's go upwards. You have b squared equals, so on the right-hand side, you put 3b to the fourth. That is 12 over 4 minus 3 over 4 is 9 over 4 b to the fourth. Therefore, that implies that our b, of course, one solution for this is b equals 0, but we require a positive solution because you note that in the figure, b is on the right. So this is b is equal to square root of 4 over 9. That is 2/3. Okay, b is the positive solution. I think we're at 20. 21, 22, 23, 24, 25. And just in case we're lacking, let me make it up to 30. 26, 27, 28, 29, 30. Okay, are we done? Of course, we're not yet done because we're looking for the value of c such that the two areas is equal. But that should be trivial because what we do is we substitute the value of b over the equation for c. So you have, let me write it here, c equals 2 multiplied by 2/3 minus 3 multiplied by 2 over 3 cube is 8 over 27. Okay, this is equal to 4 over 3, or let me write that as 12 over 9 because 3 over 27, the second term will leave a denominator of 9. So that's minus 8 over 9. C should be equal to 4 over 9. Okay, so if you take c equals 4 over 9, so we should expect it to be positive. It's above the y equals 0. Okay, when you take c equals 4 over 9, then the indicated shaded regions in the figure should be equal. Okay, so that's it for today, guys. Our problem number 6. Thanks for watching. See you next time. Bye bye.